the psalmist said in Psalm 104 verse 24, "O Lord, how manifold are your works. In wisdom you have made them all. The earth is full of your possessions." Now we'll be moving to the Ordovician period, which came after the Cambrian period. The remains of life dating back 500 million years ago were first discovered in the land of the Ordovices. The Ordovices were Celtic people who lived in what is today called Wales. Ash found in Ordovician rocks indicates that volcanoes were active during this period. Geologists estimate that the Ordovician period lasted approximately 75 million years. The abundance of fossilized remains found in many parts of the world shows that Ordovician seas were pulsating with life. Seaweeds of many types, colors, sizes, and shapes thrived in the warm seawater. Some carpeted miles of ocean floor and provided food and shelter for countless forms of marine invertebrates. Others floated and drifted as huge green islands on the surface of the seas. Green algae by far surpassed in quantity and variety all other kinds of algae. Protoctists were so plentiful that the remains of these tiny shelled animals left huge deposits on the ocean floor. Geologists today study layers created by decayed organisms because they are often the source of petroleum. The Ordovician period was particularly abundant with the petroleum producing foraminifers and Redolarians, which have been in existence since the Precambrian period. The word foraminifera means animals with open test tubes. Classified as foraminiferas were Tritosites, the Globigerina, the Camarina, and the Dentalina. So these were all known as the foraminifera. There were but a few of the minute shelled animals that lived during the Ordovician period. Within the class of the Redolarians was the Heliosphere, an organism that looked like a spiny ball. So all these here, the Heliosphere and the foraminifers, they can produce what we use as petroleum today. Within the class of Redolarians that I've said was the Heliosphere, which was an organism that looked like a spiny ball. Another was Actinoma, which populated all Ordovician seas. Here is the Actinoma. You can see that it looks similar to the Heliosphere, but it also has the capacity to produce petroleum that we use today. Now these animals or these organisms are called Redolarians because of their radiating structure. You can see how they radiate in their structure. They radiate. These are called Redolarians because they radiate. The corals belonging to the phylum Cnidaria, traditionally called Coelenterata, began to appear in the seas during the Cambrian period and became even more prominent during the Ordovician period. There were many varieties of horn-shaped corals, but Streptolasma, out of all the horn-shaped corals, the Streptolasma over here, shaped like a horn, was by far the most common of the period. Echinoderms such as the cystoids here developed in the late Cambrian and became profuse during the Ordovician. These animals lack the beauty of their descendants. They're not as pretty as their descendants. Now, sisters disappeared during millions of years after during the Devonian period. Crinoids were so bountiful in Ordovician seas that this period is also called the Age of Sea Lilies. Thousands of these colorful flower-like creatures lived crowded together in banks. So the sea lilies, they lived crowded together in banks. Here we have the sea lilies. Sea lilies were thought to be extinct for many years until a few modern varieties were discovered at the beginning of the 19th century. So we still have sea lilies very much with us today. Now, living crinoids do not have stems and can swim freely. However, in the early stages of their development, they do have stalks. These plant-like animals have three basic parts: the stem, the calyx, and the arms. The calyx consists of hard petal-like plates that act as armor to protect the subparts of the animal inside. With root-like attachments, ancient crinoids clung tightly to rocks or shells at the bottom of the sea. They built jointed stalks that swayed with the current of the water. When a crinoid was hungry, it waved its arms back and forth, which caused water to rush into its mouth at the top of its body. A sticky substance called mucus was secreted to trap algae and tiny animals inside the crinoid's mouth. When its mouth was full, it swallowed its food and started over again by secreting more mucus. Crinoids purify the seed by absorbing and digesting great quantities of calcium from the water. When crinoids died, their brittle stalks and bodies broke readily and fell to the bottom of the sea. Numerous quantities of these broken pieces accumulated in the mud and formed beds of limestone, often referred to as crinoidal limestone. The first echinoderm that resembled modern sand dollars was the genus Hemisicytes. So this was the first echinoderm that looks like what we have as the sand dollars today. It appeared during the Ordovician times and existed for tens of millions of years and became extinct during the Devonian period. Another example of an echinoderm appearing at this time was the Hudsinaster over here, which was a primitive starfish with short, thick arms. Alanoides was a common trilobite that started the Alanoides. You remember that from the Cambrian period. The Alanoides was a common trilobite that thrived in the Cambrian and Ordovician seas alike. The fossil history of these three-lobed creatures shows that some interesting changes took place during the Ordovician period. Many of these animals developed the ability to curl up if in danger. An example of a trilobite that could curl up was the Flexicolimoni here. So this could curl up when it was in danger. Another group of arthropods developing at this time were the Eurypterids, commonly called sea scorpions. The first Eurypterids were small, about 3 to 10 inches in length. Humillaria was a typical representative, just about 3 to 10 inches in length. This animal disappeared many millions of years later during the Permian period. The red line on our chart shows the development and decline of sea scorpions. You can see it went all the way, the Devonian, the Silurian, the Carboniferous, and then in the Permian period, it finally became extinct. The only modern relative of the Eurypterids is the horseshoe crab. Fossils of Raphinaskina are found only in Ordovician rocks. The brachiopod measured about an inch in length. If you remember, brachiopods are sometimes called lamp shells. Although they resemble mollusks, they are classified in a separate phylum. Within the phylum of mollusks, we find a variety of animals which lived in the Ordovician seas. The Maclurites was a gastropod of ancient relatives of the snails of today. The Cyclonema, another gastropod of smaller size, smaller than the Maclurites, attached itself to the site of crinoids where food can be found. The Polylepipod, including modern clams and oysters, are also mollusks. A polylepipod is often referred to as a bivalve because the shell in which the animal lives consists of two parts called valves. The valves are attached by hinges and held together by teeth and muscles. Even among different types of polylepipods, the two shells of these animals are similar and always symmetrical. Early representatives lived on the bottoms of muddy waters. Pisonychia here was a common pelocipod of the Ordovician period. The word pelocipod derives from Greek and means hatchet foot. The animal has a soft-shelled hatchet-shaped foot that it uses for its movement. It pushes its foot forward until it gets a good grip in the sand or mud. Then it drags its shelled enclosed body slowly forward and begins all over again. The soft-bodied polypod is without head, tentacles, or radula. The radula is a raspy tongue-like organ that sweeps food into the mouth, but the polypod does not have a radula. To feed, the polypod takes in oxygen and microscopic organisms through its gills, along with mud, sand, and unwanted particles that must later be expelled. Now, the cephalopods, also mollusks, first appeared during the Ordovician period. Cephalopods means head foot because the head of the animal is directly attached to its feet. Some cephalopods of today are the squid and the octopus, but in Ordovician times, relatives of these animals had external shells. Primitive cephalopods had long, slender shells which at times reached great proportions. Colors were often on the upper part of the shell, indicating that the head was above and the funnel was below. Endoceras was an early cephalopod that grew to 12 feet in length. Stony deposits inside its cone-shaped shell felt the animal form floating upward and enabled it to dwell in a horizontal position at the bottom of the sea. Fossil records reveal that the very first vertebrates to appear were tiny jawless fish of the Ordovician period. They were called ostracoderms, which means shell skin, because this fish had hard protective outer shells. So we've seen the Ordovician period and all the organisms that were thriving. We still have some of them today, but these are the different organisms that thrived. Some of them came from the Cambrian period, some of them formed just in the Ordovician period, some of them even still exist today, and some of them we even get petroleum that we use today from. Next, we'll be moving to the Silurian period.